and 1. When we shake or rotate the ball, it will be in any state between the 0 and 1, top or bottom. So that is the third bit. Okay, that is known as Q bit, quantum bit. Are you understand how we are getting that Q bit? Anyone from audience?
Sir, you only can speak, sir. All are muted. by
Okay,
default.
sir. Okay, sir.
At the end of session, we can.
Okay, sir. Okay, we are taking a ball. Inside that we are putting a small ball. In that it will go down or up. If it's down means it's 0. If it's in top means 1. So in digital 0 and 1, it's 8 bit. And in quantum we will have the third state. While we are rotating or shaking, it will be in between this 0 and 1. That is known as Q bit.
L11, sir.
Tell me, sir.
Are you moving the screen, sir? It is first
No, sir. Now I am telling how you can imagine the quantum computing for 5 minutes.
Okay.
Okay, sir. In olden days, if you see TV or any electronics items which uses display, a radio like that, they use vacuum tubes which are very large, and in future it was transferred to transistors which are very less in size. Each and every year it will be incremented by 2 times. In 2013 it was stopped since it reached its threshold or cross its threshold, means transistor will work in 0 or 1. So if you are in 0 or 1, if it's in mid state, so it can't identify anything. So the multiplication was stopped in 2013. It was 7 nanometer threshold, but Apple is using till 5 nanometer like our processor. So we can't see the transistor by breaking the processor or like that in natural eyes. Similarly, it is an atomic scale. These transistors and all atomic scale. So this threshold will be stopped. So after this, they are introducing quantum. To overcome this, they are introducing quantum, which is subatomic scale. Atomic scale means we know proton, electron, neutron. This subatomic scale is quarks, lepton and bosons, which have different combinations. Then this supercomputing quantum computer, okay, which will operate in 273 degrees Celsius or 0 degree Kelvin, which is a cryogenic level, which operate quantum computers. So why the temperature varies like that means it will have error corrections. Okay, what we have seen till now, we are taking a ball, in that we are placing a small ball. It will be in top means 1 and it will in the bottom means 0. This is digital world. Then if we rotate or shake means that ball will go in any place. So it is the quantum.
Sir, excuse me, sir.
Tell me, sir.
PPT running, sir?
No, sir. Sir, in starting itself, sorry, sir. Starting itself, I told no, sir. For 5 minutes, you have to imagine mind, because I can't show how the ball is shaking like that and all. No.
Okay.
So we have to imagine mind how these quantums are working.
Okay. Continue.
Okay. Then this vacuum tubes. In olden days, they have used vacuum tubes, then transistors. Now we are going for quantums, because transistors are very small in size, nanoscale, which uses atomic scale. After that, now we are using this quantum. Quantum means subatomic scale, which is quarks, lepton, boson, and its different combinations. While we are going to quantum computing, we should know three things. One is superposition, entanglement, and inference. Three things. SEI, superposition, entanglement, and inference. This is the three things we want to know. Okay. Now let's start. Okay. What we are going to see today, an overview, introduction, history, then data representation, then operations on data, then Shaw's algorithm, then conclusion and open questions from audience. Now, what is a quantum computer? Already I told why we are going for quantum computer. This 0 and 1, in between that many states are there while shaking that ball. For that we are going for quantum computing, which performs calculation based on law of quantum mechanics. Okay, till transistor we used atomic level, but in quantum computing we use this subatomic level. Till transistor, what we are using this i7 like that processor and all, we are using this atomic level, proton, electron, neutron, like that. In quantum computing we are going for subatomic level, quarks, lepton, and bosons. Okay. Introduction. Feynman told that, I think I can safely say that nobody understands quantum mechanics because it is very tough subjects. While I told that 0 to 1, while we are shaking that and all, we can't understand quantum mechanics. In 1982, Feynman proposed an idea, creating machine, which is based on the law of quantum mechanics instead of law of classical physics. Classical computing means what we are using. Quantum means next. Okay. In 1985, David Church developed the quantum Turing machine, showing that quantum circuits are universal. Now, many of the companies have discovered quantum computing and they are using. They are very costly. And what we are using in our computer, it will predict error or it will execute with error in quantum computing because it is designed for certain purpose. So it will operate for that only. While we see in coming slide, we can understand the gates and all. In 1994, Peter Shor came up with an quantum algorithm to factor very large numbers in polynomial time. Okay. Then in 1997, Low Grover develops a quantum scratch algorithm with 0 root of n complexity. Now we go for data representation, then operations on data, Shor's algorithm, then conclusion and open questions. Representation of data, qubits. Already I told, single atom is one of the two states, which is 0 get or 1 get, a single bit form known as qubit. In physical implementation, qubit use two energy levels of an atom, an existent state, one and a ground state represent 0. See here, ground state and existent state. State 0. Here, it states 1. This is the electron. This is the important thing in quantum computing. Superposition. Three things I told: superposition, entanglement, and inference. In superposition, a single qubit. A qubit means already I told here. okay, which is in superposition of two states, which will be denoted in this equation, which this is like threshold, which is known as psi get, psi or psi get. This bracket will be psi get equal to alpha 1 0 get plus alpha 2 1 get. In this, alpha 1 and alpha 2 are complex numbers. Okay, alpha 1 and alpha 2 are complex numbers, and it's also known as amplitude. And this equation entirely known as linear combinations, which will be in both state 0 and 1 at the same time. This is known as superposition. This is the important thing. You have to know superposition. While we are studying quantum, you should know superposition, entanglement, and inference. Representation of this data superposition. Okay. If you are considering 3-bit register, already you studied no 3-bit. 3-bit means 0002 to 000 is 0 bit, and for 8 for 7 you will have 111 111. See here, first 000 and last 111. This is the 3-bit qubit register, which has all possible, because 0 to 7 is 8. So we are using psi get equal to 1 by how many numbers we are using? Root of 8, 0 to 7. So it's 8. So it will start from 000 plus 1 by root of 8, 0012. Similarly, plus 1 by root of 8, 111, 7. This is the representation of the data, what we see here. Now that data retrieval. In general, an n qubit register can represent the number 0 through 2 power n minus 1 simultaneously. 2 power n minus 1 simultaneously. If we are going to retrieve any data in superposition, means it will randomly collapse. If you are having anything between the 0 bottom to top one, means if you are fetching that randomly, means it will collapse. It's one of the original value that we will see in that equation. See here what I told already. Psi get equal to alpha 1 0 get plus alpha 2 1 get. Alpha 1 represent probability of superposition collapsing to 0. Alphas are called probability amplitude, as I told already. In a balanced superposition, alpha 1 by root 2 power n, where n is the number of qubits. We will see in coming slides in detail. So it will be easy to understand. It will be a little bit confused because it's very complex, because it's the combinations of mechanics, physics, etc. Then we are going for entanglement. Already I told superposition we have seen. This is the superposition equation. Okay, psi get equal to alpha 1 0 get plus alpha 2 1 get. This alpha 1 and alpha 2 are probability amplitude, and this equation is linear combination. Next, as I told, entanglement. Okay, first I will tell how you can understand easily. Okay, I am placing two subatomic level, one in India and one in America. Whatever the changes I am making here in India, it will affect in America. Similarly, what changes are made in America, it will be affected in India. That is the entanglement. If you are having a laser crystal of polarity 90-degree means, then here if I change anything means it will be affected in USA, like that in both state, which will be used in blockchain also, because we are storing our data in multiple systems. So if we change in one system, it should affect in all the systems. Sorry. Similarly, imagine two qubits, each in state 0 get plus 1 get, a superposition of the 0 and 1. If we entangle these two qubits such that measurement of one qubit is always correlated to the measurement of other qubit. What I told, if we change anything or anything affected here means it will affect that same in another place also. Always correlated to the measurement of other qubit. This is entanglement. If we are having a twins means whatever one person is doing, that another person also do the same thing. This is entanglement. Three things we have to know. One is entanglement, superposition. Superposition we saw, that psi get equal to alpha 1 0 get plus alpha 2 1 get. Then this entanglement means one qubit measurement will be correlated to another qubit measurement. Next, inference. These are the three things we should know. Okay. Similarly, in quantum waves represents states. If electrons, protons that subatomic level are moving means it in waveforms. It has multiple states simultaneously. Okay. From a particle be in superposition of being two locations. From here to one place to another place means it will have multiple states. Then wave amplitude. When the waves are in multiple movement, it will overlap and their amplitude will combine following the superposition principle. Okay. Then we are going to Shaw's algorithm. Operations of qubits. My kind request, please listen carefully here. Then only it will be easy to understand. Operations of qubits. It is reversible logic. Due to the nature of quantum physics, the destruction of information in a gate. See here we are using AND gate, which can destroy the superposition of qubit. See here, AND gate we are using. What it will do? Multiplication. This is the simple AND gate multiplication. A, B and C. It is the output, all we know. 0 0 equal to 0, then 0 1 is 0, 1 0 is 0, then 1 1 is 1. This type of gate can't be used in quantum computing, so we use quantum gates. See the input and output here, quantum gates. These are reversible, which are similar to classical gate, but it will generate the output which are reversible, derived from the output state. Okay, this means discriministic computation can be performed on a quantum computer only if it is reversible. It's also known as discriministic computation, which made reversible. See here, this is the simple quantum gates. HADMAT. Simplest gate involves one qubit and is called a HADMAT gate. Simple gate, which is also known as square root of NOT gate, used to put qubits into superposition. See here, two ADMAT gate, which represented in H. One state is 0 and another one state is 1. In between that 0 gate plus 1 gate state. Here we are connecting two ADMAT gates. Used in succession can be used as a NOT gate. See this input and output. Here in next slide I will show. See here. A gate which operates here. One is target, another one is control. A is the target and B is the control. We will have one target and multiple control we can have. A gate which operates on 2 qubits are called controlled NOT gate or CN gate. Controlled NOT gate or CN gate if you use 2 qubits. If you are having only one line means invert the bit on the target line. See here what we are getting, A and B. Okay, A and B 0 means this target and B control are 0. Similarly, see here in this definition, if bit on the control line is 1, invert the bit on the target line. If the bit on the control line is 1, okay, control line means B. B is 1 means invert the bit on the target line. If B is 1 means then A also 1. Okay, understood? 0 0 means 0 0. B is 1 means here in output A will be 1. Similarly, B is 0 and A is 1 here. That will be same. Then another in both 1. So while we are doing NOT operation, here 1 will become 0 in output. At last, if we give target and control is 1 1 means it will give 0 at target. If we have B is 1 means it will also A will also be 1. If A also 1 means it will be not to 0. This is the simple CN gate, controlled NOT gate. Then we are going for multiple by 2. Reversible logic circuit. Okay. To calculate multiplication by 2 using CN gates, arrange the following manner. Carry bit and input. Carry bit and ones bit. Carry bit and ones bit. If both are 0 means 0. If 0 and 1 means carry bit will become 1 because 1 bit will become 1. So this carry become 1. Here it will become 0. See here. One NOT gate H. This is for CCN gate. In this we have 3 qubits. Here see this slide. If the bits on both of the control lines is 1, both should be 1. B and C control line. B and C are control line and A is the target line. If both are 1, then the target bit is inverted. Target bits means A will be inverted. See here, all will be similar. First 0 0 0 will be similar, 0 0 1 will be similar, then 2 also similar. In 3, B and C are 1. So this A will be inverted. Here 0 means it will become 1. Similarly, other will be same. Then here B and C are 1 at last for this 7. Here this A will be inverted. Understood? This is the logical operations in quantum CCN gate. If anyone want means take screenshot of this or take photo. Just look at this, how we are getting. If control line is 1 means it will be this target line will be inverted. Similarly, if B is 1 means A will be inverted. Similarly, here also B is 1. Similarly, A is inverted 1 to 0. 1 will be converted to 0. This is in controlled gate, controlled NOT gate. Similarly, here we are having 3 qubits. Similarly, what will happen here means 2 control line is 1 means then this target will be inverted. See here for this B and C are 1, then A is 0, so it will be inverted to 1. Similarly, B and C are 1, A is 1, so it will be inverted to 0. This is the operation performed. Okay. What happened means here it use simply XOR gate. Okay. XOR gate with some extra information to make it reversible. XOR gate for 2 qubits, controlled not CN gate. Similarly, here what it use means NAND gate. Okay, output result of a NAND gate of B and C. Next we move to Shaw's algorithm. If you understand this only, it will be easy to understand this Shaw's algorithm. While we are going for Shaw's algorithm, we should know factoring. Factoring is the important thing for Shaw's algorithm. Shaw's algorithm shows that a quantum computer capable of factoring very large numbers in polynomial time. Very large number factoring in polynomial time. In that, if you are going for that means we should know modular arithmetic, quantum parallelism, quantum Fourier transform. These 3 things we have to know. First, let's see modular arithmetic. Shaw's algorithm is main thing, factoring very large numbers in polynomial time. Okay, the computer capable of factoring very large numbers in polynomial time. That is the important thing, which is depending on modular arithmetic, quantum parallelism, quantum Fourier transform. First, let's see Shaw's algorithm periodicity, which has f of a equal to x power a modulus of n is a periodic function. F of a equal to x power a modulus of n is a periodic function. For this, now we are taking n equal to 15 and x equal to 7 modulus. What we take? Okay, what we will take first, f of a equal to x power a. X power a means 7 power 0, 7 power 1, 7 power 2, 3, 4, 5, like that we will go. Modulus of what is here? N. So 15, 15, 15. Okay. What we modulus 7 power 0 is 1. Okay. 7 power 0 is 1. Then 7 power 1 is 7. How, if you want to know this calculation means I will show. One minute. I'll stop and I show.
Leland sir, do you need any
Sir,
support?
yes, sir, yes, sir, yes, sir. I am taking that Word document, sir, for that calculation.
Okay.
See, for given n equal to 15 and x equal to 7, how we are computing means 7 power 0. 7 power 0 mod 15 means 7 power 0 equal to 1. So 1 mod 15 means the remainder is the modulus. So 1 divided by 15 we will get the remainder will be 1. We are not using here in point. Similarly, if 7 power 1 means 7 will be there. So 7 by 15, 7 will be the remainder. So modulus of 7 power 1 mod 15 will be 7. Okay. Similarly, we can calculate for 7 power 2 modulus of 15 equal to 4 and 7 power 3 modulus of 15 equal to 13. And this is the important thing we want to know while we are going for quantum. In this polynomial, what we are using means 7 power 0, 7 power 1, 7 power 2, 7 power 3 will be 1, 7, 4, 13. After this 7 power 3, 7 power 4, 7 power 5, 7 power 6, similarly, it will repeat. The values will be repeated 1, 7, 4, 13, etc. Then we will move to Shor's algorithm. To factor an odd integer n, let's choose 15. Okay. For choosing an integer q such as n square less than q less than 2 n square. For this q let's use 256. Then for random integer x, okay, such that GCD of x comma n, we will pick 7. Okay, now we are going to use two quantum register, which must also be entangled so that the collapse of the input register correspond to the collapse of the output register. What affects in input register will be affected in output register also. See here, one register is input and another one is output register, which contains n of q bits to represent numbers as large as q minus 1. Q minus means what we are taking here is q is 256. So 256 means 0 to 255. So we have to use q minus 1. So our value should be up to 256. So we need 8 qubits. 8. Then the output register, which contain enough qubits to represent n minus 1. So here we are using up to 14. Here it's mentioned 15, n equal to 15. So minus n minus 1. N minus 1 is 14. So we need, for representing in digital, we need 4 bits. Till 7 we need 3 bits, 1111. So after this 7 to 15 we need 4 bits. Now load the register with equally weighted, okay, 0 to q minus 1, then 0 to 255. Q minus 1 is 255. So load the register with all zeros. Load the register, output register with all zeros. So total state, this is the formula. Input register and output register. For output register, we have loaded with 0 for all this. Then for input register, 1 divided by square root of 256, summation of a equal to 0 to 255, q minus 1, 255. Here is q, 1 by root of square root of q. Then here a equal to 0 to 255. Then output register will be 0, 0, 0. See here. For simply we are understanding, we are taking here as decimal numbers. Digital means represented in 1 and 0, 0 and 1. Now we are taking 7, 4, 13 like that. So here transformation of x power a modulus of n. Okay, x power 7 power 0 modulus of n is 15. Already I told for input register 0, 1, 2, 3, 4, 5, 6, 7 till 7. Okay, 7 power 0 mod of 15 equal to 1 output register. 7 power 1 mod of 15 is 7. Similarly, we are going for 7 power 2 mod of 15 equal to 4, then 7 power 3 mod of 15 equal to 13. Then similarly 7 power 4 mod of 15 is 1, then 7 power 5 mod of 15 is 7, then 7 power 16 mod of 15 is 4. Similarly for 7 power 7 mod of 15 will be 13. Similarly it will go. So if you see here means first 4 values you check 1, 7, 4, 13. After that again it will be repeated 1, 7, 4, 13. So this will be confused. Now we take the measurement on the output register. This will collapse the superposition to represent just one of the results of the transformation, because 1 gate, 4 gate, 7 gate, similarly 13. Again it will go for 1, 4, 7, 13. Okay. So for the namesake we are taking just first one we are using this one. Let's choose 1. Then we will compute here. Since the two registers are entangled means if it affects input, it will be affected in output. So it's entangled. Measuring the output register will affect partially collapsing the input register into equal superposition. Is state 0 and Q minus 1. That yielded C, the value collapsed output register. Since output is 1 gate, collapse to 1 gate, the input register will partially collapse to, which will be addition of 4. Okay, see here 1 by square root of 64, 0 gate plus 1 by square root of 64, 0 plus 4, 0, then 4 multiplied by 1, then 4 multiplied by 2, then 4 multiplied by 3. Similarly it will go till this Q value, Q minus 1 value. So 0, 4, 8 like that, 64 like that, it will go till 252. Okay, for that we will get superposition of 64 values like this 0, 4, 8 like that. We will get 64 values. Why we are using this 1 by square root of 64 means we will get superposition of 64 values. So we are using here 1 by square root of 64, 0, 1 plus 1 by square root of 64, 4 get plus 1 by square root of 64, 8 get plus 1 by square root of 64, 12 get similarly till then. Quantum Fourier transform. Okay. First, what we see modular arithmetic, then quantum parallelism. Then now we are going for quantum Fourier transform. In quantum computing, whatever thing we study or prepare for one time means we can't understand clearly. So we have to study at least 2 times or multiple times. Then only it will be understood easily. Now we will go for quantum Fourier transform. quantum Fourier transform which is partially collapsed in input register. This input and all what we are using, see here, this is the input 1 by square root of q c equal to 0 to q minus 1 c. C is the collapsed value. The Fourier transform has the effect of taking the state A. See here. This is the quantum Fourier transform equation. This is the equation we saw early. Input. This is the output. Okay. See here. 1 by square root of 64. A belongs to A. A get 1 get. Here it will be 1 by square root of, this is the output state, this is the input state, 1 by root 256 c equal to 0 to 255, collapse, get multiplication with e power 2 pi IAC slash 256. Similarly, now we are going for A is the set of values that 7 power A. What we are using 0, 4, 8, 252, what we mentioned here. 0, 4, 8, 252, what we have mentioned here. And 7 power A and modulus of 15 yielded 1, which we saw here. See, GCD of x comma n equal to 1. So on final, we can write off 1 by square root of 64, A belongs to A, then 1 by square root of 256, C equal to collapsed value 0 equal to 255, collapse get star e power 2 pi IAC slash 256, 1 get. See here, QFT, quantum Fourier transform. This integer multiples of q by 4, 256 by 4 or 64, which can be written 0 get, 64 get, 128 get, 192 get. So we no longer have superposition of states. The probability amplitudes of the above state are now higher than other states in our register. So with collapse which has highest probability of one of these multiple, which will be of 64. Let's call the value of P. With our knowledge Q and P, there are methods of calculating the period. One we are having, one is continuous fraction expansion of the ratio between Q and P. Now here, Shor's algorithm, 3 factors. We have the period, the factors of n can be determined by taking the greatest common divisor, GCD, greatest common divisor of n with respect to x power p by 2 plus 1 and x power p by 2 minus 1. The idea here is that computation will be done on a classical computer. See here, 15. GCD of 7 power 4 by 2 plus 1, 7 power 4 by 2 minus 1. We are getting 5, 3. Successfully, it will be 15. This quantum Fourier transform comes with short and reveals wrong period. This probably is actually dependent on choice of Q. If the Q is larger, then higher probability of finding correct probability. If it's lower, means there may be chance of less probability only. mostly the probability period series ends up being odd. Similarly, we go to beginning and pick again new value of x. Similarly, we have to process. Then overview introduction is what are the things we have saw today. Introduction history, data representation, operations on data, Chor's algorithm, conclusion and open questions. Conclusion. In 2001, a 7-qubit machine was built and programmed to run Chor's algorithm to successfully factor 15. What are the calculation we saw now? Then what algorithm is discovered next? Can quantum computer solve NP complete problems in polynomial time?
Participants, dear participants, if you have any questions. Dear participants, if you have any queries.
Hello, sir.
Sir, tell me, sir.
Sir,
Yes,
my
sir.
name
Yes,
is
sir.
Raj.
Proceed.
The thing is, I was keen to know what is that is called as error correction, sir. In
Okay,
any
okay,
of
sir.
the yes, sir. In any of the algorithms which we are using presently, there is a scope wherein we can give or contribute towards error correction methods. So, how do we evaluate these errors? Like you calculated in this equation, sir. Can you put some light on that so that we can understand, sir? Hello, sir. Am I audible,
Yeah.
sir?
Yes, sir. Yes, sir. Yes, sir. I'll answer for your question, sir.
Yes. Yes.
Sir, actually, error correction which will cause in quantum computer uh, by noise or the temperature, it will work in certain temperature only. So, if the temperature varies or some noise or imperfect operations like that, quantum error correction codes and SHA codes, stream code and surface code encode logic qubits into multiple physical qubits, sir. Error detection correction without violating the no cloning theorem we will use, sir.
Okay. Okay. And how do we evaluate that, sir? Like we still don't know what would be the output. We have given certain input to a unknown hardware. We don't know
Yes,
what
sir.
is the output, and we still don't know if the environment or the heat dissipation is adequate or no. How do you know that it is the proper output in order to evaluate that, sir?
Sir, that is the problem we are facing in quantum, sir. So only we are many scientists are working on that. Since whatever thing we are working in our classical machines, if we work in quantum machines, means it will cause some errors, sir.
Okay, then I understand that, sir. I understand the context of what you're trying to put it up, sir. Let us break down how this Shore algorithm can work, sir? If we are giving certain input, what would be the expected output of that algorithm, and how do we justify that the output is right or wrong? If they have already built an algorithm, there should be
Okay, sir.
some justification of how we evaluate that. We will not talk about other things, sir. Only with respect to Shore's algorithm, how can we conclude, sir? Am I audible, sir?
Yes, sir. Yes, sir. Yes, sir. Sir, for verifying the errors in Shark's algorithm, we have to check the quantum circuits accuracy, sir. Quantum circuits accuracy by validating
Okay.
periodicity estimation and increasing the number of measurement shots. Like that, we have to repeatedly do, sir, and analyze hardware noise level, sir, and ensure proper configuration of post processing, sir.
Okay.
We have to check the quantum circuit accuracy, sir. Then periodicity estimation and increasing the number of measurement shots. Analyze the hardware noise levels. Noise levels means you understood, no, sir? This
Yes,
temperature and
annotations and all.
yes, sir, yes, sir.
Signal annotations or other
Yeah, yes,
things,
sir.
vibrations, those kind of.
Yes,
But
sir.
is there any set frequency, sir, that the noise or the vibration should be this much only? Is
No,
there
sir.
any
No,
limit
sir.
for that?
It's under research, sir, because they are in
Mhm.
subatomic levels. So many
Subatomic,
scientists
okay.
are working.
Understood. Understood, sir.
Yes,
Understood.
sir.
So there's still a lot of scope in exploring those things.
Yes,
Thank you
sir.
so much, sir. Thank you so much.
Sir, another one question I saw in chat: quantum algorithms for cryptography. If we include this Sharp's algorithm in cryptography, means it is capable of giving large integers, so we can break the security key itself, sir. Someone asked in chat quantum algorithms for cryptography. If Sharp's algorithm, which breaks classical public key crypto systems by factorizing large integers and quantum key distribution, such as BB84 protocol, it can overcome the security also. This Sharp's algorithm, if we use means in cyber cryptography like that and all. Password can be encrypted or it can be identified easily.
Hello, sir.
Yeah, tell me, sir.
Sir, one basic doubt, sir. Sir,
Okay.
in your beginning of this slide, you told the visualization. It was very
Yes, sir.
wonderful, and visualization is very essential to understand any environment.
Thank you so much, sir.
Sir, one basic doubt what I am having is 2-qubit or multi-qubit. How to visualize this 2-qubit and multi-qubit, sir?
Sir, 2-qubit is like 2-qubit, multi-qubit means the tabular column you are having, no, sir, A, B, C. In slide I showed, no, sir.
Because
The
in
target
first,
and control. Target and control. If
Oh.
in Shah's algorithm slide, if you see means, I'll share, sir.
Okay. And because 1 qubit only we can use the ball sphere for visualization purpose.
Yes, sir.
And all the concept what you told, I can able to correlate it. But if suppose if 2 are multi-mean, then what way we can visualize it? I think yesterday one speaker told that Hilbert space can be used. But Hilbert space, how to visualize the Hilbert space? That I'm not able to understand, sir.
Okay, sir. If time permits means any other
Sorry to interrupt, sir. Sir,
session,
yesterday
I
speaker,
will handle, sir.
what they told, yesterday speaker, what they told about Q cube and multi cube, sir. I think
sir.
the difference of 2 cube can be factorized into the product of binomial times and trinomial, sir. So that is what they want to try to explain. Drawing the Q cube means the base horizontal line and vertical line. That is the meaning of the 2 cube. And multi cube, what they want to try to explain, the data divided into the smaller cube. So like we discussed in data warehousing and data mining, the multi-dimensional, we much aware about that subset of the available dimension, 2 dimension, 3 dimension, like that. That kind of things only they want to explain in yesterday, as of my knowledge, sir. Sorry to interrupt. It may be right or wrong. Oh, we are observing like that only, sir. Am I right or?
Sir, I also know somewhat only about Hilbert space. It's a complete vector space, sir. As I told, inside the ball like
Try
that.
to
Yes, sir.
explain about the 2 cube and your question is 2 cube and multi cube. How to some are different 2 cube.
Yes, sir.
Yes. The thing is some of the different or two cubes can be factored into the product. That is what the binomial time and trinomial. For example, the calculation of x square, y square. So that will be explained into x minus y and x square, like that. Mathematical computational. But the thing is the dimensional factorized only they want to convey, as of my knowledge. I'm remembering that. Over to you, sir. Elil, sir. Please continue,
These
sir.
are the 3 things we should know for quantum, sir. Superposition, entanglement, and inference. If you know this means, somewhat idea means we can handle all this, sir. Hilbert space, everything we can study, sir.
Sir, good evening, sir. Shall I add something regarding this?
Yes, sir.
Sir, actually, as far as my thing is that if you consider 2 qubits, then we can represent the 2 qubits mechanism in 4th dimensional vectors.
Okay, sir.
The 4th dimensional vectors may not be visualized through our eyes.
Yes, sir.
Just it is something like higher dimensionals rather than 3-dimensional. Until 3-dimensional only we can visualize.
Okay,
It is
sir.
one type of assumption only. Even the Hilbert space or higher level dimensions, it could be difficult. Just as an assumption only, we can calculate the things.
Okay,
I
sir.
hope means how far it is correct. I mean, it is my idea to attain this solution, this problem. Visualization is not completely is not as easy as we see the single qubit mechanism as block space spheres. Hilbert spaces, even the Hilbert spaces are good enough to understand the things rather than the visualization.
Exactly, sir. Sir, what they told exactly, that is what the Silver scans told that.
Yes, sir. Yes, sir. Correct only, sir. As sir said, because it's difficult, because we are having door sphere, amplitude and phase graphs, then tensor networks like that and all. It will be very difficult to visualize because it has higher dimensional or multi-qubit systems.
Thank you very much, sir, for your insightful and engaging session. So, dear participants, the session feedback link is available in the chat box. So, kindly take a moment to fill out the feedback form. Thank you so much, sir.
Thank you so much for participants, and thank you so much, sir, for giving me this opportunity. Thank you so much.
Thank you, sir.
So, Vinod, sir, session 8 speaker joined or not, sir?
So, after 7:30, we will connect, sir. So, we will announce short break to the audience. So, after
we will
7:30.
give 10 minutes to fill up the Google form.
Yes, sir.
Okay, fine.
So dear participant, the feedback link is available in the chat box. So kindly take a moment to fill out the feedback form.
Also, sir, give some instruction about the examination timing and also, Vinod sir,
Yes, sir, sure.
attendance thing, and then
Sure, sir, sure.
a lot
So
of questions arise related to attendance. Just
Yes.
clarify to the participants.
Sure, sir, sure. So dear participant, the attendance is updated daily basis. So due to large number of participants, so we are finalized the attendance. So we will confirm at the end of the faculty development program. So don't worry about that. So we will kindly request you to remain patient during this process. One more announcement. So assessment exam schedule for an 28/12/2024. So on Saturday. So your request to log in your ID and complete the assessment. So as per the instruction. So once it is done, so if you're not at feedback form, so it won't go generate the certificate. So time will be announced shortly. So we request your cooperations in this regard.
Any dear participant, any other doubts related to the final examination and attendance? Just raise your hands or unmute and ask the doubts. Sir.
So it is a MCQ question. So it will be announced the time. So based on the time schedule, you can complete it. So based on this assessment, so we are going to provide the marks. So and it will be generate your certificates.
Hello, sir. You'll be giving any
Hello, sir. Am I
question
audible?
back, sir?
Yes, sir. Yes, ma'am. Please.
You'll, ma'am. Sir, it is. You will be giving any question back, like the same.
No question back, ma'am. Based on
no,
this
ma'am.
session, so.
Yeah, sir. Vinod sir, just a minute, sir. Sorry to interrupt. Ma'am, you go to your ATAL login, ma'am. You get some material. We post
Okay,
some
sir.
material. You read that material. That's enough to answering the questions.
Okay, sir. Thank
Four
you.
materials we have uploaded. Once you
Uh-uh.
enter into your login and check it under
In-
the FDP details, I think so.
Okay, sir.
In
Can you
that
say
section, you get some PDF. We are
where
uploading
we
some
should check
PDF files.
details? So what is the menu where we have to go and check it?
I think you go to your menu, madam. We don't know about the participants menu.
Okay,
Definitely, your menu available in that PDF. 4 PDFs are available.
Okay, sir.
You
Check it,
read
sir.
out all the 4 PDF. Definitely, you will get the questionnaires and further you are what you are expecting.
Okay, sir. Thank you, sir.
Thank you.
Sir, PDF is available in the ATAL account?
Hello, sir. Am I audible to you?
Yes,
Yes,
sir. Yes,
ma'am.
sir.
Sir, the MCQ bank is provided at ATAL FDP or it would be provided itself?
Sir, ATAL portal itself, you have menu, sir. That means assessment exam. You click on that assessment exam, you'll get the questionnaires, MCQ type of questionnaires. On the day and the particular time only that will be enabled.
Oh, available, no, sir?
No, sir. Only on that day, the end of the day, the particular time, duration only, that question portal will be available. The link and everything will be available.
So can you tell the time for the exam? Said the PDF is available, 4
Thank you,
PDFs
Just
are
a minute,
available.
ma'am.
Is
I'll
it
check in
available?
and yeah, please. I'll check it and tell you, ma'am. Sure.
Okay, is it available on the ATAL account
Yes,
only? We need to
portal.
check it.
Your portal itself, you may find some PDF material
Okay.
that are available. Just give me a few minutes.
Okay.
I'll check it and tell you
Sir,
that.
on which
Sure,
tab it
sure,
is
sure.
provided? Just now I have logged in onto the ATAL portal. Can you guide on which tab it is being provided? The notes.
Just a minute, sir. I'll check right now.
Sir, we will announce shortly, sir.
I'll
We will
guide you.
announce it. So we will.
It is already provided. I have just checked. It is an important
Yes.
document.
Please wait, ma'am. Please wait. Now I am checking.
Sir, where is chat box? Hello.
Just a minute, ma'am.
Yes, ma'am.
Where is chat box?
So at your right hand side corner, ma'am.
That hand.
Yes, sir. On the left hand side panel where
Yes.
participant is there, important document is there. Yes.
Yes. You click on the important
Yes,
document
yes.
section. You may get some PDF, right? Dear
Okay.
participant, log in your ATAL website. Important document. The left side menu. Important document. You may get some PDF. That means material. Introduction about quantum computing, computer science, machine learning with quantum computing and new quantum cryptography principle and application security computing, and future of quantum computing in computer science research. So these are the 4 documents available in your portal, participant portal. You just read on the document. This is sufficient for answering all the questions, I think so.
So 1 minute, sir. This is for this 4 days. No, future will be uploading, or this is only 4 document we have to go through for test. Hello, sir. It's audible.
Yes, madam, audible only. So this is
what is-
supporting material for the participants to attending the exam.
Okay,
Just we
sir.
want to upload some supporting documents.
Okay, so in future also
We
you'll
are
be adding some more.
daily updating the source person PPT. That's
okay,
also
sir.
enough to answering. Additional document you may find in your portal itself. Assessment document. Under the
Okay,
section
sir.
of-
We got it, sir. Thank you very much, sir.
Yes, yes, yes. Thank you so much, madam.
Ma'am, sir, examination through ATAL website only, no?
Yes, sir. Yes, sir. ATAL portal only, sir.
Through the portal only, we have to write the exam during the
Yes,
stipulated timings.
Yes, yes, definitely.
Okay, sir. Thank you.
On that important documents, 3 links are there. Sir, 3 links are there. In out of that 3 links, only 1 link is active, and only that particular 1 link, 4 documents, 4
Yes,
documents
yes,
are
yes.
there. And
Yes, sir. Yes, sir.
in another 2 links, no documents are there, no, sir?
We have 1 or 2. We may upload it in near future. For your reference purpose only, we are putting.
Okay. So just for the sake of knowledge, I wanted to ask that these documents would be sufficient to solve the MCQ, or our knowledge while gaining this running of FDP would also be required, and these documents would be essential to solve. Any other question bank could be provided by the organizer?
No, sir. We are not providing any question bank and all.
So
go through
PPT
the,
will be shared in
speakers.
group, sir. You can refer it. So that is sufficient.
Okay. Yes, yes.
For the PPT of all the session experts.
Yes,
and
yes.
then this material, assessment, important document material.
Only one last question, sir.
Yes.
There would be the criteria to qualify the MCQ to get the certificate, or whether it just merely attending and pass exam of MCQ would be making us eligible for getting the certificate?
Yes, sir. That also we posted in the group. Vinod sir, can you explain the criteria, eligible criteria?
So you need to score 70%, sir. So then only you will qualify for the certificate, getting the certificate.
For MCQ, for passing the exam, up to 70% is required.
Yes, yes, sir. Yes, sir.
Okay. Thank you for guidance.
Thank you very much, sir. Thank you. Dear participant, the next session will be start by 7:30. So dear participant, we are getting a lot of message regarding this attendance. So attendance is daily updated on ourselves. So we are finalize the update at the end of the faculty development program. So so kindly request you to maintain patience during this process. Sir, Ajinkya sir, are you available here? Ajinkya sir, are you there? Good evening all. So we will go to the day 4 session 8. So it's my great pleasure and honor to extend a warm welcome to our esteemed resource person for today's session. So Mr. Ajinkya Lokhare, CEO and founder of Ditto Security, Mumbai. So we are truly privileged to have him with us today for this enlightening discussion on quantum cryptography and principles and applications in secure computing. So he is renowned computer security expert and passionate broadcaster who expertise in cyber security has earned him a distinguished reputation globally. He has delivered keynotes and presentation at numerous prestigious conferences around the world, including Joe's Talk, Wait Talk, and Deya's Conclave and Data Security event, sharing his invaluable insight on securing this digital world. So his extensive experience and expertise in the field have not only earned him accolades but also established him as a leader in cybersecurity. Among his many achievements, he has been honored with Business Series Entrepreneur Award and Indian Business Award for Startup in 2019, a testament for his innovation approach and significant contribution to this industry. On behalf of all the participants, I extend a warm welcome you, sir. Welcome, sir. Sir, welcome, sir. Sir, my voice is audible. Sir, can you? Oh, dear audience, so the next resource persons will be connect within few minutes.
Me now? Hello.
Yes, sir.
Sir,
Yes, sir.
yes, sir. Audible, sir.
Audible, right? Fine. Okay, so I'll
This is
share
audible, sir.
and then we can start.
You can share your screen, sir.
Okay, fine. You just let me know if the screen is visible or not. It's visible? Screen?
Yes, sir.
Okay, so I'll start now. Fine. So good evening, everyone. So from India, indeed, my name is Ajinkya, and I am a computer security expert, computer security guy. And I know what you people think about the computer security experts. So the computer security experts are the one who are always telling you the no. No, you can't do that. No, you can't use that services. No, you cannot set up that new thingy. You can buy and use the devices not in our network. So I am sick and tired of telling people no. So I have decided to change the way of I'm working. And from now on, every time somebody come and asking me whether they want to do something in our network or like, something, anything in the network. And that time I will always say yes. Yes, that's okay. Yes, you can. Yes, but because of course we have to take computer security into considerations in everything we do. But we can't let it the security slows down. We can't let it the security keep us down because we all are working on the internet. We all are working on at a very high phase of innovation and we can't let it the security slow us down. So we should be thinking about security is an enabler, security as an enabler, and security is what enables us to do what we want to do. And nowadays now, we already seen too many revolution. We've seen the first way of revolution, that is internet revolution, right? We've seen the second way of revolution, that is cloud computing. And now we are in the third revolution, that is quantum computing. I mean, quantum computers are coming. So what is quantum computing? And it's just a booming trend, right? So what is the quantum computing? I'll tell you very, in simple manner only. So with the help of quantum computing, you can find out the solution for the AIDS and the cancer. You can predict the stock market. You can predict the future. You can predict the multiple things. So this is all about the quantum computing. And with the help of quantum computing, you can do any impossible things. I mean, I don't know when, but during our lifetime, today I'll talk everything, like artificial intelligence, quantum computing, cybersecurity, everything. And I'll give you the bunch of knowledge. So I don't know when, but during our lifetime, you will be sitting down your home and you're watching Netflix or Z5 or any other platform, and you have options there. You can select the Salman or the Lady Gaga, Salman Khan as the main lead. You can select the Lady Gaga as a female lead. You can select yourself, why not you? And the future Netflix render it for you and you cannot watch a movie. And this will happen because of the computing power, not because of the artificial intelligence. I repeat once again, this will happen because of the computing power, not because of the artificial intelligence. One more thing. How many of you use the iPhone here? In your iPhone, you have a 3 nanometer chips. I repeat once again. In your
Sir, excuse me, sir. Your voice is not audible, sir. Now it's okay.
Okay, it's lagging or what? You just tell me in the chat section. Okay, fine. So the Mars Zuckerberg IQ level is like 100, 196, 198 for the Elon Musk. And I will make a quote here. the man with 100 IQ declared what 100x or the million x AI IQ will do. So in the future, we really don't need the human beings. In the future, we really don't need the content editors or the musicians. Why? Because of the machines, because of the computers, because of the quantum computers, because of the artificial intelligence. And the last summer, I mean, you all heard about the last summer. The many big companies, again, not audible? Seriously.
Your
Sir,
screen
it
is
is
not,
audible, sir. Your screen is not shared.
No, sir.
you shared,
Okay.
but it's
This one,
not
no?
showing the PPT.
Now
Now
it's
it's
okay.
audible. It's visible.
Yes, sir. You can carry on.
Okay, fine. So, with the help of artificial intelligence, with the help of quantum computing, you can solve multiple things, multiple problems. Now, I'll talk about what is quantum computing. So, basically, in our mother nature means what? Our outside things, our natural things, they are not based on the zeros and the ones, right? They are not based on the binary things. They are based on the atoms, they are based on the electrons and the photons. So, what is quantum computing? Quantum computers are a new kind of computers that use the strange and powerful rules of quantum mechanics, the science of tiny particles like atoms and the electrons. Because in the classic computers, what we'll do? We are using the binary things like zeros and the ones. You can't use it the zero and the ones everywhere. So I repeat once again, what is the quantum computing? Quantum computers are a new kind of computers that use the strange and powerful rules of quantum mechanics. Unlike regular computers that use the binary code, that is zeros and the ones, quantum computers use the qubits, which can do many things at once. And this makes them super powerful for certain type of problem. I mean, just think about it. With the help of quantum computers, you can solve any problem. It's related to the AIDS, it's related to the cancer, it's related to the Alzheimer's or anything, right? Now, today I talk about now three different things like past, present, and the future of quantum computers. Past, present, and the future of quantum computers. So let's talk about the past thing. Okay, I repeat once again. I'll just get back here. In 1901, in 1901, off the coast of Greece, a shipwreck was discovered that was 2000 years old, containing a computer of unimaginable power and sophistication. So basically, in the era of 19, they found out, like they find the left-hand side thing, then the scientists reassembled it, and then it got like some extraordinary device, then we got some extraordinary product, like wow product, and this is like analog computer. So in 1901, off the coast of Greece, a shipwreck was discovered that was 2000 years old, containing a computer of unimaginable power and sophistication. So thousands of years ago, ancient Greeks made machines called the AICTE mechanisms to track the planet and predict the eclipses. It was like a very advanced analog computer for its time. And you can check it out, this one. It was the world's first and most powerful analog computers designed to track the motion of the sun, moon, and the planet. I repeat once again, in 1901, off the coast of Greece, they found out the left-hand side. The scientists reassembled it, and we got the analog computer. So it was the world's first and most powerful analog computers designed to track the motion of the sun, moon, and the planet. This is like 2000 years advanced thing. Okay, means computers was developed in 1901 only. And this, why they are using the analog computers? Because they need to track the motion of the sun, moon, and the planet. Okay, now basically this kind of devices totally operates on computers, and these are totally based on, like, the gears and the pulleys. Okay, now let's talk about the Charles Babbage. In the early 80s, the Charles Babbage, the founder of the computer, built the most advanced analog computer of its kind. Unfortunately, he ran out of money and never finished it. I repeat once again. First of all, we got the first analog computers in 1901. Then in the early 80s, there is a scientist, or you can say the founder of the computer, which is like Charles Babbage, the founder of the computers, built the most advanced analog computer of its kind. Unfortunately, because of money and the dispute, he never finished it. Then we have another one of the finest programmer, the Lady Lovelace, became a student of Babbage and became the world's first computer programmer. One could calculate the Bernoulli's numbers from her program. I repeat once again. First one, the first computer we found out in the 1901, that is analog computers. These are the computers based on the gears and the pulleys. Then we have in the 1880s, early 80s, we got the one computers. This is the founder of computer, like advanced analog computer of its kind. Unfortunately, ran out of money and never finished it. Then, what is the difference between classic computers and the quantum computers? I repeat once again. What is the difference between analog computers and the classic computers? I hope my voice is audible now, right? Tell me.
Yes, sir. Yes,
Yes,
sir.
sir.
It's audible, right? Cool. So basically, what is the difference between the analog and the quantum computers? So basically, in the classic computers now, they'll check the possibilities one by one. They'll check the possibilities one by one. But in the quantum computers, you can do all the possibilities at once. You can check all the possibilities at once. So I'll give you the example here. Imagine you are trying to find the fastest route in a city with million of possible routes. What? Imagine you are trying to find the fastest route in a city with a million of possible routes, while a classical computer would take each and every road at a time, right? Means each one road at a time, right? But what the quantum computers will do? A quantum computers can explore all the routes at once and dramatically speeding up the problem solving. So with the help of quantum computing now, you can solve the multi-level problems. Okay, you can solve the multi-level problem. So these are all other like analog computers I'm talking about. I'm talking about the past now. Okay, analog computers and the digital computers. Now, basically, our economy is totally reliant on the digital computers. Nowadays, our economy is totally reliant on the digital computers. Now, let's talk about the Enigma machine. Now, what is the Enigma machine? This machine was used in World War II. What? This is like Enigma machine. This machine was used in the World War II. So during the World War II, the Nazis used the Enigma machine to code its top secret war plans, and it became the priority of the Allies to crack the Enigma code. I repeat once again, this is the one of the machine, Enigma machines. Why they are using it? They are using it for the conversation purpose. So during the World War II, the Nazis used the Enigma machines to code its top secret war plans, and it became the priority of the Allies to crack the Enigma code. So they are finding out the mathematicians, because they are not able to crack the code. They are not able to crack the mathematics things. So they are finding out the mathematicians like Alan Turing. I hope you all know about the Alan Turing, one of the finest, you can say, the founder of artificial intelligence and the fine tuning, right? So Alan Turing helped to crack the Enigma code, saving the life of perhaps hundreds of thousands of people, and he helped to build the modern digital computer. Means we saw the first era, that is analog computers. Then we saw the second era, that is digital computers. Now we are in, and now we are seeing now third one, that is quantum computers. So what is the Alan Turing? Who is the Alan Turing? Alan Turing helped to crack the Enigma code, saving the lives of perhaps hundreds of thousands of people. He helped to build the modern digital computers. Now you can check the quantum computing and its origin. I repeat once again, you can check the quantum computing and its origin. My screen is visible? Yes? Or I need to share once again?
Yes,
Okay, fine, it's visible, I think. It's visible, no? Okay, clearly audible. Fine, thank you. So let's talk about the quantum computing and its origin. So first one, that is like analog computers, that is Antikythera mechanisms, a 2000 years old mechanical computer discovered in the Mediterranean Ocean, which tracked celestial bodies and predicted the eclipses. This ancient device was far more advanced than its time. Then the second one, that is digital computer, or second one is also the analog one. Charles Babbage, the founder of computer, created an early mechanical computers but lacked funding to complete it. His work is foundational to modern computing. And the third one, that is Lady Ada Lovelace. This is one of the first programmer, the world first programmer responsible for writing the first algorithms for the Babbage machine. Okay, first programmer responsible for writing the first algorithm for the Babbage machine. Now, who is the Alan Turing? So basically, Alan Turing, cracked the Enigma machine code. He helped to crack the Enigma machine things. Alan Turing is the father of digital computers and the artificial intelligence. He created the Turing machines. All computers are today based on the Turing machines with the computer tape and the processor with well-defined rules. Then he committed suicide after being arrested for being a gay. Okay, so he's one of the finest, what you can say, one of the finest founder of the artificial intelligence. So Alan Turing is the father of the digital computers and the artificial intelligence. He created the Turing machines. All computers are today based on the Turing machines with a computer tape and the processor with all defined rules. He committed suicide after being arrested for being a okay. Okay. Now I suggested 2 or 3 things here. If you want to do some research and development in the quantum computing era, I suggest you some roadmaps.
Sir, your voice is not audible, sir. Yes, sir. Yes, sir.
It's lagging or what?
It's not lagging, but it's not audible sometimes.
Okay, I really don't know, because of the network maybe. Okay, I repeat once again, what kind of textbook you need to check? Number 1, that is quantum supremacy. Okay, first textbook you need to check. Now it's audible, right? First textbook you need to check, that is quantum supremacy.
Now it is not audible, sir.
And again,
Now it's okay.
Okay, fine. Just a minute. I'll just change the network. Just give me a second. I'll just change the network. Wait a minute.
Okay, sir.
Hello. Can you hear me? Now it's audible? Hello. It's
Yes,
audible?
sir. Yes, sir.
Okay.
Yes.
I repeat once again. If you're going to do some research and development in the quantum computing, you need to check the 3 textbook. Number 1, that is quantum supremacy. If you want to start everything from the scratch to the advanced level now in the quantum computing, just go for it.
Again, the same issue, sir. It is not audible.
Now it's audible. Hello, can you hear me?
Yes, sir. Yes, sir.
So you need to check if you are in the research and development, click here to kill everybody. Then second one, data in Goliath. Third one, supremacy, quantum supremacy. Okay. Now, and one more thing, please.
Sorry for the interrupt, sir. Again, it's not audible.
Just a minute, I'll just. It's audible, sir. Please tell me.
Audible,
Yes,
sir.
sir. Audible.
Screen is visible. I don't have like network issue here because I have proper internet connection.
I didn't see your PPT.
PPTs are here only. This one, right? It's
Yes, sir.
visible, no?
Yes,
Okay,
sir.
fine. So I suggest you 3 textbook here.
Again, it is not audible,
Sir,
sir.
I think you click on the browser, the audible not audible problem.
Okay, because of browser. Okay.
Yes, sir.
Yes, exactly, sir.
Now here is it's audible, no?
Now it is
Yes,
fine,
sir.
sir. Sometimes it is
Your voice is audible while display the PPT and all.
Okay, fine. I understand that. Anyway, so I'll suggest you 3 textbook. Please try to check. Number 1, quantum supremacy. I'll just put it in the chat section, okay? First one, quantum supremacy. The first textbook. I'll just put it in the chat section so you can easily check. Second one, click here to kill everybody. Click here to kill everybody. I hope my message is visible, right? Yes or no? And the third one,
Yes, sir.
Data and Goliath. Data and Goliath. These three things you need to check if you want to do some research and development. Okay. I think I suggest you go for the quantum supremacy. There you can learn everything about the quantum cryptography, quantum computing. Okay. Quantum supremacy, click here to kill everybody, data and Goliath. Then one more channel I suggest you here. If you are from any background, please try to check the fine tuning series. Turing series. Turing series you need to check. Turing series on quantum computing. Okay, Turing series on the quantum computing. This part also you need to check. Turing series on the quantum computing. One more stuff. Okay, so basically we already discussed about the analog computers and the digital computers. Nowadays, your economy is totally depend on the digital computers, right? So this is a machine. This Enigma machine, which was used like in a World War. During the World War II, the Nazis used to the Enigma machine to code its top secret war plan. So basically, they are using this machine for the conversation purpose. And this is like Alan Turing. He cracked the Enigma machine code. He is a mathematician. Okay, so the Alan Turing helped to crack the Enigma code, saving the lives of perhaps hundreds of thousands of people. He helped to build the modern digital computer. Okay, now you can check the quantum computing and its origin. Okay, so first one, that is analog computer, which was like there in 1901. Second one, Charles Babbage, one of the founder of computers, created an early mechanical computer but lacked funding to complete it. Number three, one of the finest computer programmer, computer programmer, that is Lady Ada Lovelace, the world first programmer responsible for writing the first algorithm for Babbage machine. Now, who is Alan Turing? Alan Turing is the father of the digital computers and the artificial intelligence. He created the Turing machines, and nowadays all the computers are today based on the Turing machines with a computer tape and processor with well-defined rules. I hope now audio is fine, right? Yes or no? Please tell me. Because again,
Yes, sir. Yes, sir.
Fine. Great. Now, do you know this guy? This is like Richard Feynman. So basically what he said, our mother nature is not totally reliant on the zeros and the ones, right? Just think about the photosynthesis. Photosynthesis is also the process of quantum computers only. Photosynthesis is also the process of quantum computers. They are the quantum computers. So what he said, he proposed the ultimate computer, which computed on atoms, not transistors, right? Because nowadays we have a digital computers, right? He proposed the ultimate computers which computed on atoms, not transistor, but atoms cannot easily described by the series of zeros and ones. Atoms behave like waves, right? I repeat once again. He proposed the ultimate computer which computed on atoms, not transistor, but atoms cannot easily described by series of zeros and the ones. Atoms behaves like one. So he said we have to go beyond the digital computers. So what is the next one then? So Mother Nature does not use the digital. I mean, the nature does not use the digital things like zeros and the ones every time, right? Digital is alien to the Mother Nature. Digital is alien to the Mother Nature. Zeros and ones, zeros, ones again and again. We can't use it. So nature is the real quantum mechanical. Nature is real quantum mechanical. Nature believes in electrons waves, the uncertainty principle. Okay. So nature is a quantum mechanical. So he is the one who enters into the new era, who gave the waves to in the new era. Okay, so I repeat once again, he proposed the ultimate computer which computed on the atoms, but atoms cannot described in the series of zeros and the ones. Zeros and the ones you can't use everywhere. Atoms behave like waves. Okay, now analog computer, what beyond that? I repeat once again, just a minute. Analog computers, now what beyond that? So we have a Moore's law here. And what the Moore's law says? Moore's law says that computers' powers double every 18 months. What? What is the Moore's law says? The Moore's law says that computers' power doubles every 18 months, but we are now reaching the end of Moore's law. Computers' powers flattening out with time, and Silicon Valley become a rust belt, right? So we are just flattening out the Moore's law. Moore's law says that the computer's powers double every 18 months, but we are now reaching the end of the Moore's law. Computers' powers flattening out with the time. Silicon Valley become a dust bag. Now this is a process of hydrogen wave function. Look at on the right. Look at on the right. That's how physicists look at hydrogen atoms. We don't see the hydrogen atoms as the zeros and the ones, right? We see them as the waves. I repeat once again. How you can make the water. Look at on the right side. That's how the physicist looks at the hydrogen atoms. We don't see the hydrogen atoms as the zeros and the ones. We see them as the waves, electrons waves, a new way that Mother Nature uses to do computation. When you walk outside and you see the vegetation everywhere, do they use the zeros and the ones? Zeros and ones? Is that now how Mother Nature create the world around us? No, everything is quantum mechanical. So the Richard Feynman said it is only a matter of time. So we can't use the zeros and ones everywhere. Our Mother Natures don't use the zeros and ones. Our vegetations don't use the zeros and ones. So this is the image of hydrogen wave function. Okay, you need to check the biography about this person. This is like Nobel laureate like Richard Feynman. Then I'll talk about how the quantum computers is why the quantum computers is very powerful. Now let's take a example. So elementary understanding of why quantum computers are so powerful. So in a magnetic field, I'll just tell you the example. In a magnetic field, atoms can spin up and down. What? In a magnetic field, atoms can spin up and spin down, right? This represent zeros and the ones, right? But in the quantum computers, atoms can spin up simultaneously in all the direction. I mean, what the classic computers and the quantum computers will do, classic computers only check some probabilities, but in the quantum computer, you can check all the directions simultaneously, right? So quantum computers is infinitely more powerful than a digital computers. Not up and down, not only that, but your states, when you rotate in any direction, you calculate it in this state simultaneously. Now that's violates the common sense also. Okay, I repeat once again. I mean, in the classic computers, what we can do, that is spin up, spin down. But in the quantum computers, you can spin each and every single directions, right? And you can analyze it. So in the magnetic field, atoms can spin up, spin down, that is zeros and ones. But in the quantum computers, atoms can spin simultaneously, not up and down. Not only that, but your states, when you rotate in direction, you calculate in this state simultaneously, and that violates the common sense also. So this is like one of the finest technology, one of the finest thing. Then we have a second example here, that is mouse maze. To walk through a maze, digital computer records each and every turn for each path. I repeat, we have a different paths, we have a different ways to go to the exact location destination, right? So to walk through a maze, digital computers records each and every turn for each path, and this is a tedious and slow. But in the quantum computers, all the paths are computed simultaneously. This is vastly increases the power of quantum computers. So you can check all the probability at once. You can check all the directions at once. You can analyze anything at one single point. Okay, so this is the power of quantum computing. Okay, I repeat once again, to walk through a maze, digital computer records each and every turn for each path. This is tedious and slow, but in quantum computers, all paths are computed simultaneously. This is vastly increases the power of quantum computers, right? Screen is visible now, or again it's like not visible? Oh, fine.
It's visible, sir.
It's visible. It's visible. Fine. Okay. So this one you need to check. Now these things already exist. So this is like US based quantum computers. This whole thing is not a quantum computers. In the bottom you have quantum computers. Okay. So in a quantum computer, the slightest vibrations can ruin the calculation. In the quantum computers, the slightest vibrations can ruin the calculations. And to keep the atom vibrating coherently, you have to cool the quantum computers to the near absolute zero. Then we have Chinese quantum computers. So one possibility to replace the electrons with photons of laser light, because light speed is faster than the electricity. One advantage is that light travels faster than electricity. The Chinese are the leader in this technology, because most of the big giants, I mean IBM, Microsoft, they are investing a lot of money, because nowadays the next thing, I mean economy is totally related to the quantum computers. So one possibility to replace the electrons, and nowadays Chinese top they are on the top in the quantum computers. So they released the 2 quantum computers. You need to check the white articles about the Chinese quantum computers. So one possibility to replace the electrons with photons of laser lights. One advantage is that light travel faster than electricity. The Chinese are leaders in this technology, but the collection of beams, mirrors, splitters is still complicated. So you need to check the whole process, how quantum computers you can build, okay, which is not a simple task. Then atoms can talk to each other. In a digital computers, each transistor independent of each other. In a digital computer, each transistor independent of each other. In a quantum computers, all atoms are entangled with each other, with information flowing between them, increasing their power. Means you can talk with them, right? Then let's talk about some quantum computing power, like what you can say, some quantum computing products. So after 1 or 2 years later, this product is already exist. This is like contact lens. Okay, I repeat once again. This is one of the finest product by the quantum computers, and this is like contact lens. You can use it in your eyes, it could be in your earrings, it could be in your contact lens, and this is the internet contact lenses. I repeat once again. This is a contact lens. It could be in your earrings or it could be in your contact lens. This is the internet contact lenses where you can access the internet by blinking. Where you can access the internet by blinking. And if the internet is in your contact lens, communicating with the quantum computer in the cloud. So basically your quantum computing things is in the cloud only. Who will buy these things? So first of all, who will buy this contact lens? Number one, that is college students, right? I repeat once again, it could be in your earrings, it could be in your contact lenses. This is the internet connected contact lenses. And the internet is in your contact lens, communicating with the quantum computer in the cloud. Who will buy these things? Well, college students studying for the final examinations. So basically with the help of blinking, you can check the questions and the answers there. Will be among the first to buy internet contact lenses. They will blink and all the answers to my exams will be right there in their contact lenses. This is the power of quantum computing. Okay, you need to wear the the lens. That's it. You can check the questions, you can check the answers, even you can check the people's biographies there. So quantum lens advantages, number one, who will also buy them? These contact lenses will also identify people's identity. Just looking at them, you will know who they are, what languages they speak. It will translate these languages. For example, let's say you are on a date, okay, and your date says that he's rich, single, powerful, and available, but your contact lens says no, he's a loser. Okay, so this is like advantages. This is a new kind of internet. This is a new kind of thing. Okay, the next generation, and it will take like decades. I think it will take 5 to 10 years to do everything. So contact lenses. This is all about the contact lenses I'm talking about. You can check the questions and answers. You can check the biography of the other people. Okay, like you can check everything on the internet through your contact lens. Then next one, that is child support payments. This guy, stay away from this guy. He's a poison. Very important that you know who are you talking to instantly. You are looking for a job. And one more thing, when you go to any cocktail party with your lenses, you can check it out everything about each and every single person. So very important things that you are at the cocktail party and you want it for your job. Like you are just searching your job, and there is some very important people at the cocktail party, but you don't know who they are. In the future, you will know exactly how you can find out the exact person at any cocktail party. Very useful, and these things actually already exist. So you need to check the contact lens. So your contact lens identifies stranger, print out their biographies in your lens, and translate their language into English just by blinking. So this is the extra level innovation, the contact lenses I'm talking about. So no one can cheat you, no one can beat you. Again, you're getting some problem, Rhea. Can you hear me now? Hello.
Problem in the editing PPTs.
What's is lagging, I think, no?
No, sir. No, sir. You go ahead, sir. Nothing issue.
Okay, fine. Okay, fine. So this is like a contact lens. Your contact lens identifies the stranger, print out their biographies in your lens, and translates their language into the English just by blinking. This is the how the quantum computers work. This is the image of photosynthesis, Mother Nature. In some sense, plants are like a quantum computers. In some sense, plants are like a quantum computers, processing the energy of the sunlight and creating the oxygen in process, right? This is all about the oxygen. And this is a challenge to create a room temperature quantum computers. I repeat once again, this is a process of photosynthesis. In some sense, plants are like quantum computers, processing the energy of sunlight and creating the oxygen in the process. And this is a challenge. Now, these are the use cases of like quantum computers. Nowadays, NASA has urged the aircraft industries to produce supersonic jet without sonic boom. Supercomputers can simulate supersonic jets without sonic booms from New York to Tokyo in 3 hours. I repeat once again, nowadays the aviation companies, they are investing a lot of monies in the quantum computers. So NASA has urged the aircraft industries to produce supersonic jet without sonic boom. Supercomputers can simulate supersonic jet without sonic booms from New York to Tokyo in 3 hours. So in the future, you'll have a breakfast in New York, you'll have an afternoon tea in Tokyo, and you'll have like dinner in the New York again. So we are talking about the new era in the space travel. Then we have another example, which is called as like Starship, right, by Elon Musk. So we are talking about the reusable rocket that can go to the moon, Mars, and beyond. This is an interplanetary rocket, reusable rocket. I repeat once again, with the help of quantum computers, you can use the reusable rocket that can go anywhere to the moon, Mars, and beyond that. And this is an interplanetary rocket. It's called the Starship. The original name for this rocket, the biggest rocket in existence. So this one also, this case study also you need to check. The first one, that is like sonic booms. Second one, that is reusable rocket. Third one, nowadays the automobile industries, I mean Mercedes, they are using the quantum computers for the quantum battery simulations. They are using the quantum battery simulations. I repeat once again, nowadays nowadays, most of the automobile companies, they are using the quantum computers for the so automobile makers are using quantum computers to design cars that are fuel efficient. So Mercedes also, they are using the quantum computers to build the design car. Okay, so automobile makers are using quantum computers to design the cars that are fuel efficient. Then we have one more trend, that is solar era. Now, why aren't we are in the solar age? So one problem is the battery, which is the weak link. I repeat once again, solar era, why aren't we are in the solar age? One problem is the battery, which is the weak link. We need the quantum computers to design super battery when the sun doesn't shine, winds don't blow. Why aren't solar age? One problem is the super battery when the sun doesn't shine and the winds don't blow. Now, third one, that is very important. Nowadays, people are facing too many problems with the cancer, Alzheimer, Parkinson's. This is the disease. You can't find out the medicine for that, right? So all these diseases operates at molecular levels. All these diseases operates at the molecular level. Quantum computers may one day decipher the molecular secret of incurable disease, such as cancers, Alzheimer's, and many more. I repeat once again, these are the incurable disease. Like all disease operates at the molecular level. Quantum computers may one day decipher the molecular secrets of incurable disease, such as cancers, Alzheimer's, and many more. Okay, so just a minute. Okay, so this is all about the, okay, let's talk about, this is all about the cancer. Okay, all the diseases are on the molecular levels. Quantum computers may one day decipher the molecular secrets of the incurable. Then we have another one, that is like Alzheimer, right? In the Alzheimer, we have two type of proteins, two type of amyloid proteins. One theory says that there are two types of amyloid protein which cause Alzheimer. Perhaps one day quantum computers might help to eliminate the bad version of this protein and cure the Alzheimer. So with the help of quantum computers, you can resolve this issue. So one theory says that there are two type of amyloid proteins, only one of which cause Alzheimer. Perhaps one day quantum computers might help to eliminate the bad version of these proteins and cure the Alzheimer's. And one more thing, you heard about the the quantum computers are now being used at the Large Hadron Collider. I hope you all know about this one. This is universe we are creating nowadays. So quantum computers are now being used at a large headquarters in Geneva. We are hoping to reveal the secrets of the creations of the universe by smashing protons apart and analyzing computers. So one day, a quantum computers can find answers to the questions, why are we here? Right? So you know the secrets and you know everything. Why are we here? So quantum computers are now being used at the Large Hadron Collider in Geneva, and we are hoping to reveal the secrets of the creations of the universe by smashing protons apart and analyzing the data using quantum computers. So one day, a quantum computers can find out the answer to the questions, why are we here? Even one day, transistors will be as small as atom, and we will compute not on bits but qubits, that is quantum bits. And it is still decade away. Silicon Valley became a rust belt. Then this is the Big Bang theory. I hope you all know about the Big Bang and the multiverse, right? So perhaps the one day quantum computers will reveal the secret of the Big Bang. Why did it bang? How did the Big Bang create the universe we see around us? Okay, so with the help of quantum computing, you can solve the multiple problems. Why we are here, then you can solve the problems about the Big Bang theory and multiple things you can solve it. So perhaps the one day, the quantum computers will reveal the secret of the Big Bang. Why did it bang? How did the Big Bang create the universe we see around us? Then one more thing with the help of quantum computers, you can solve the issues of reverse aging. Can we live forever? This one. So aging is the buildup of errors in our body and at the level of our DNA and cells, but science can reverse and stop this process. Maybe, I really don't know. This is my personal opinion. Maybe in the future, reverse aging is possible. I mean, we can live forever with the help of quantum computing. I really don't know it's going to be happen or not, but I have some opinions. So it's maybe possible because of the quantum computing. So aging is the buildup of errors in our bodies at the level of our DNA and cells, but science can reverse and stop this process. So number one, the issues we have, why do we have to die? Well, there is a second law of thermodynamics, which says that in a closed system, everything eventually gets old, falls apart, rust and corrodes, right? I repeat once again. Why do we have to die? Well, there is a second law of thermodynamics, which says that in a closed system, everything eventually gets old, fall apart, rust, corrodes, and dies. In other words, it's a law of physics that you have to die. But there is a loophole. There is a loophole in the law of physics. Notice that I say that the second law of thermodynamics says that in a closed system, all things must eventually fall apart. The key word is closed. In an open system where you have energy from the outside, technology from the outside, you can in principle stop at the aging process. We don't have to die. For example, in a car, where does aging take place in a car? Think about it for a moment. Where does aging take place in your car? The engine. Why is that? That's where you have oxidations. That's where you have combustions. That's where you have like moving parts, the engine. Well, what's the engine of a cell? You now know where aging take place in our body. You now know why you will eventually die. And then the question is, can we go around the second law of thermodynamics with the quantum computers by seeing they able to correct the mistake? Because so basically, maybe with the help of quantum computers you can solve this problem. So aging is the buildup of errors in our bodies at the level of our DNA and the cells, but science can reverse and stop this process. So let's talk about the cancer. Using computers, AI, and the rapid gene sequencing, we can eliminate costly and biopsy and identify the cancer years before it arrives, right? I mean, how you can identify the cancers? We identify the cancers because of with the help of tumors. I repeat once again, how we identify the cancers? We identify the cancers with the help of tumors. And nowadays we have the FDA release the FDA last year only the FDA released one test. I mean, you can taste the cancer. I mean, you can taste the cancer through the blood. You can taste the cancer through the blood. Okay, I repeat once again. Means you need to do a lot of things for the cancer, like MRI, multiple scans you need to do, CT scans, MRI scans you need to do. But the FDA released one thing that is with the help of blood also you can analyze, you can check the cancer. So using the computers, AI and the rapid gene sequencing, we can eliminate the costly and biopsy and identify the cancers years before it arrives. One more thing, with the help of quantum computers, you can check the 50 plus cancers at a single time through what you can say, the blood test. I repeat once again, with the help of quantum computers, you can check the 50 plus cancer test at the same time. So using the computers, AI and the rapid gene sequencing, we can eliminate the costly and biopsy and identifies the cancer years before it arrives. So by the time you have a tumor, you go to the doctor and doctor says it could be too late. By the time you have a tumor, you have to over an billion cancer cells going in your body, right? A billion cancer cells going in your body in the future. We will do it with a blood test. I mean, I already discussed about the FDA. So already this year, for the first time in the world history, the FDA made it commercially available a blood test that detect the 50 plus different type of cancers. Let me repeat that again. Up to now, there was no way to tell whether you had a cancer or not until you found a tumor or some obvious symptoms. And by then, sometimes it was too late. Now we have a blood test, a simple test that can pick up 50 different kind of cancers. In the future, this will hooked up to the quantum computers to detect the 100, maybe 1,000 of different type of cancers growing in your body. So with the help of quantum computers, you can solve the errors of cancer, Alzheimer's. Then these are the fundamentals of quantum computing. I repeat once again. So first, you should know about what is quantum computing. You need to check the 3 textbook. If you don't know anything about the quantum computing, so you can check the encryption techniques, you can check the decryption techniques, how you can assemble it, you can check then the talk about you can check it out the analog computers, digital computers. Then what are the difference between the classic and the quantum computers? Then what at the stake, that is digital economy, how we'll communicate with the quantums. In the future, quantum computers might be in the cloud, so you can contact with through your contact lenses, but you will have a communicate using the probably a digital access to a quantum computers in the cloud. This interface could be in your wristwatch, it could be in your earrings, or it could be in your contact lens, and this is the internet contact lenses where you can access. This is all about the Enigma machine. Then we have Alan Turing. You need to check the series of fine tuning. This series you need to check. Hi sir, all of those operations where we can get the data sets. So basically, if you want the real-time data sets, you can directly get it from the Kaggle. Or one more thing, you can go for the website called as Black Hat. Or one more thing, you can check the series called as fine tuning. Turing lecture series, you'll get all the databases, all the data sets there. I repeat once again, please try to check the series. I'll just put it here. First one, you can go for the Kaggle. Second one, you can go for like the another one, that is the Royal Institute London. The Royal Institute London. You can add the JNAI here. Third one, you can go for the lablab.ai. Lablab.ai. If you want the data sets about anything, you'll get it here. Okay, please try to check these things. Okay, now just try to learn the things about the Alan Turing. Who is Alan Turing? You can check the theories of computers, thermodynamics, quantum computing and its origin. Then Alan Turing is the father of digital computers. You can check the documentary about the Richard Feynman. Then check it out the Moore's law. Okay, the hydrogen wave functions. You can check the multiple examples of how quantum computers work. So these things exist in the quantum computers. The slightest vibrations can ruin the calculations. To keep items vibrating coherently, you have to pull the quantum computers to the near absolute zero. You can check the problems with the quantum computers, how you can use the quantum computers and can solve the multiple problems in the solars, in the automobile industries. You can use it in the aviations, solar industries, automobile industries. You can use it everywhere. Like in the medical industries also you can. Even more than that, how you can make a drugs. Nowadays, how you can make a wonder drug. To find a wonder drugs, thousands of drugs must be tested via the trial and errors, which enormously expensive. I repeat once again. To find a new wonders drugs, thousands of drugs must be tested via trial and errors, which is enormously expensive. In the future, drug may be tested in the memory of quantum computers. I repeat once again. In the future, drugs may be tested in the memories of quantum computer. So if you want to build some extraordinary drugs, you need to put it in the quantum computers, memory of quantum computers. So in the future, the memory of quantum computers, so quantum computers will do the chemistry also. Okay, this is all about the Alzheimer's. If you want to remove any bad one proteins, you can remove it with the help of quantum computers. So even quantum computers used in like corridors in Geneva, we are hoping to reveal the secrets of the why we are here. Then one day transistors will be small as atom. We will be compute not as a bit but qubits. This is all about the Big Bang theory. Perhaps the one day quantum computers will reveal the secret of the Big Bang. Then can we live forever? You can do the reverse aging with the help of quantum computers, because the cars, they never die, right? Like, I mean, you can check it out the multiple things. So why do we have to die? So you need to check, you can solve the problems with the quantum computers. This is all about the cancer. Using the computers, AI, and rapid gene sequencing, we can eliminate the costly and biopsy and identify the cancer years before it arrives. This is the fundamental of quantum computing. Number one, qubits. In classical computing, information is stored in bits, which can either zeros and one. In quantum computing, information is stored in qubits. A qubits has two keywords, that is superpositions and entanglement. Okay, I'm not able to do anything here because I'll just demonstrate, but I don't have a time. So first one, that is qubits. In a classical computing, information is stored in bits, that is zeros and ones. In the quantum computing, information is stored in qubits. A qubits has two key properties. Number one, superposition, and number two, entanglement. Then we have a superposition. What is superposition? Superposition is a fundamental concept in the quantum mechanics, where particles can exist in the multiple states. I repeat once again, superpositions is a fundamental concept in the quantum mechanics, where particles can exist in the multiple state simultaneously until they are measured. Then the classical analogy and the quantum advantages. A classical coin is either head or the tails. A quantum coin in a superpositions could be both heads and tails at the same time until it is observed. Number two, quantum advantage. By operating in a superposition, a quantum computers can process multiple possibilities at the same time, which allows it to solve certain problems much faster than classical computers. So this is all about the you need to check it out about the quantum interference, entanglement, then the quantum gates and the quantum circuits, the measurements, quantum speed up. These are the use cases of quantum computing. Number one, cryptography, where you can use the quantum computing. Number one, cryptography. One of the most talked about the use cases for the quantum computer is in cryptography. Particularly, so with the help of quantum computing, you can break the cryptography also. I mean, you can easily crack anybody's password. So one of the most talked about use cases for the quantum computers is the cryptography, particularly in breaking encryption system that rely on the large numbers such as RSA encryption. Then first one, quantum threat to the classical encryption. Quantum algorithms like Shor's algorithm can efficiently factor large numbers, breaking current encryption methods used in secure online communications. Number two, quantum resistant cryptography. On the flip side, quantum computers can be used to develop new, more secure encryption techniques that are resistant to the quantum attacks. Means you need to find out the new encryption techniques to tackle the cryptography, to tackle the quantum computing. Use cases of the quantum computing, second one, that is drug discovery and the molecular simulation. Quantum computers can simulate molecular structure and the chemical reactions at a level of detail that is far beyond the capability of classical computers. Quantum computers can simulate the molecular structure and chemical reaction at a level of detail that is far beyond the capability of the classical computers. Number one, molecular modeling. Quantum computers can simulate the behavior of molecule, allowing for faster drug discovery by identifying promising components or reaction. Number two, material science. Quantum computing can also help design new material with specific properties, such as supercomputers, by simulating the atomic interactions at the quantum level. Then the third one, use cases of the quantum computing, that is optimization problems. Quantum computers excel at solving optimization problems, where the goal is to find the best solution from a large set of possible solutions. So this also you can do it. Fourth one, that is machine learning and the artificial intelligence. Quantum computing can enhance the speed and efficiency of machine learning algorithm by processing large data sets and complex models faster than classical computers. Number one, quantum machine learning. Quantum computers could accelerate the training of machine learning model, especially in the task involving large amount of data or complex pattern recognition. Number two, pattern recognition. Quantum algorithms can potentially outperform classical approaches in detecting patterns in data, such as image recognition, speech recognitions, and natural language processing. So first one, that is one of the finest important, that is like cryptography. Second one, drugs. Third one, optimization. Fourth one, machine learning and the artificial intelligence. Next one, that is climate change, climate modeling and the weather forecasting. Quantum computing can simulate complex systems such as Earth atmosphere. I repeat once again. Sir, as you see, the QC will describe the DNA structure for the Alzheimer. Please explain that. Sir, I have a proper documentations about it, the practical things. If you want, I'll share the proper documentations with you. You just post your email ID. I'll share the proper white papers, like how you can remove the bad one proteins. If you want, you just post it, your things there. You can solve the multiple problem related to the, like, the cancers and other thing. Okay. So you just send it to me. You just post your email ID if possible. So I'll share all the documentations with you. So use cases of the quantum computing. Next one, climate modeling and the weather forecasting. Quantum computing can simulate the complex systems such as the Earth atmosphere with the much greater precision than classical supercomputers. Like weather predictions, quantum algorithms could improve the weather forecast by simulating the atmosphere behavior and its interactions with oceans and land surfaces more accurately. Second one, climate change models. Quantum computers could also simulate complex climate models to better understand and predict the long-term impact of climate change, helping to guide policy decisions. So I'll show you some white papers, some learning resources. Maybe my voice is not audible from now on, but you can check the resources. If you want, you can take a screenshot. Okay, I repeat once again. Now I'll show the resources, white papers. Please try to check it out. Okay, you can, if you want, you can take a screenshot. So first one, the research article called as "Attention is All You Need." Research article, this one. Research article called as "Attention is All You Need." This research article you can check. White paper I'm talking about. The God equation. The God equation. The first textbook you need to check the God equation. Just a minute. Apart from the shows and the grooves algorithm, any other specific algorithms you can integrate with the ML, you have a multiple options there. You can go for the RSA also. You can directly do it with the RSA. RSA algorithms, you can use it. You have a list. I share the list of algorithms what you can use it for the cryptography purpose or in the ML. You can check this textbook, The Dark Forest Analogy of the Internet. So the data set, please tell me. Not audible. Can you hear me? Hello. Again, voice is not audible. Just a minute. Can you hear me?
Yes, audible.
Okay, okay, fine. And one more thing.
Excuse me, sir, your voice is not audible, sir. Yes, sir.
Hello. Can you?
Yes,
Okay.
yes.
Okay, when you are switching between tabs, only when we lost the audio voice, fine. So I suggest you some things like Darknet Diaries, go for the DEFCON, go for the Black Hat. I have a lot of resources, but because of some technical issues, I'm not able to show anything. I'm not able to give you anything. But anyway, fine, it's okay. So if you want any material or anything, you just post your queries on my LinkedIn. Okay, I hope you have my LinkedIn ID. Volume is very low. Again, I'll just tell you once again, if you have any problem, if you want the documentations or any other part, you just post your queries on my LinkedIn. This is my LinkedIn profile. You just post your queries there. I'll share the documentations now. It will take some time. Okay, fine. Maybe my voice is audible or not. I really don't know.
It is audible, sir. Now it's okay.
Okay, fine. So participants, if you have any problem, you just post your queries here. Okay, I'll solve all your queries. Fine then. Sir, are you there?
Sir, yes, sir. Thank you very much, sir, for insightful and engaging session. It's very truly informative and valuable. Thank you, sir.
Thank you, sir. Thank you so much.
Thank you. Thank you so much, sir. Thank you. Dear participant, the session feedback link is available in the chat box. Dear participant, the feedback link is available in the chat box. So kindly take a moment to fill out the feedback form. Dear participants, tomorrow day 5, session 9, the resource person, Dr. R. Jyotilakshmi, Assistant Professor, Mazaralum College, Ambur, Tamil Nadu, on topic quantum computing application in software development. So day 5, session 10, Dr. M. Malini, Associate Professor and IEEE Senior Member, SA Engineering College, Chennai.
Hello. Hello.
Yes, sir.
Yes, sir, I have a query there. Am I audible?
Yes, sir. Please.
Dr.
Yes, sir. Yes, sir.
Ajankia, first of all, I thank him for shedding light on some future developments that can be possible with quantum computing. I am a physicist basically. So my query is that he compared between classical spins and quantum spins on a slide. If we can go back to that, I will be happy. He is there?
No,
Hello.
sir. No, sir. No, sir. He's not available.
Oh.
So if you have any queries, just
now actually I had a confusion there. So when he compared that spins, I mean classical spins on quantum spins in an external magnetic field, especially in an external magnetic field, quantum spins, even if it is quantum spin, it can take only certain discrete values, what we call spatial quantization. Means that are the only possible states a particular spin can take in an external magnetic field. But he talked about a superposition which is like it can take any value like that. I didn't actually get him what he was trying to
sir,
explain there.
I shared a LinkedIn ID, just you can contact, sir. So that is beneficial for you. Dear participant, the assessment schedule on 28/12/2024 on Saturday. So you are requested to log in into your ID and complete the assessment as per the instruction. So we are not yet scheduled the timing. So as soon as possible, we will share the schedule. Okay. So we request your cooperation in this regard.